Okay, so hi everyone. My name is Sundip Shah. I work at the Advanced Technology and Research Group at Arup, and today's webinar is on an introduction to THIS. I'll be talking about version 14.0, but the webinar equally applies to version 14.1. So today, my goal is to tell you about the principles of THIS, a summary of the results files that THIS can read, how to read in those files. I'll talk to you a little bit about the user interface, the curve manager, formatting your graphs, manipulating data and looking at multiple graphs, quick pick options. So this is how you sort of move around the screen and do things quickly. I'll talk about some of the operations that THIS can do to manipulate your data, how to output the files, either as images or curve files. I will also give you an introduction to the fast TCF scripting method. And this is a very important and very useful item in THIS. I'll also talk to you about macros. And along the way, I will give some very simple demonstrations about what I've been talking about. Okay, so THIS is designed to allow easy access and manipulation to time history data. And it's specifically designed to read in LS-DYNA binary and ASCII files. So you don't need to make any changes at all to the output of the files from LS-DYNA. THIS will read those in directly. So there's no there's no sort of manipulation to do there. You don't need to write a script to change the formatting of the files. THIS will read everything in directly. Curves can also be read in from other sources, for example, CSV files, or the native format for THIS is the curve file, which is .cur. You can also read in curves from your input files, so those are the defined curves and defined tables. Those can be read in by THIS, or you can even, if you wish, you can manually type in data. Curves can be operated on. Examples are filtering, mathematical functions, or combining x versus time with y versus time to obtain x versus y. So let's say you had a stress versus time and a strain versus time. You could combine those to produce a stress strain plot. Plots are easily formatted, and once you've made all the adjustments that you wish, curves can easily be written out in either the native curve format, in a CSV file, or even Excel native format. And we can also write out image files, PNG, bitmap, or JPEG. THIS can be run as a standalone program, and that's how I will demonstrate it. Or we can embed it within D3plot to synchronize time history values with animations. So that's very useful. So we can play through the animation whilst plotting some time history data. Okay, so just some basics. This is all sort of more on the LS-DYNA side, but in LS-DYNA, we have to request data before the analysis runs. So THIS will only show you the data that is available, which is that has been output by DYNA. But you know, if you're running LS-DYNA, you have to request that data beforehand. And just the output is requested, for example, in database ASCII, database binary, and database history for things like element and node histories. So just one little thing is, confusingly, database ASCII files can be requested in both ASCII and binary formats. So THIS will read all of those. Okay, and this is just an example of the files that THIS will read. For example, these are typically called ASCII files, glstat, matsum, nodeout, and so on. You can also have the binout files. Again, those are database ASCII files. So this is time history data. And we can also request THF files. So that will be under database binary. Okay, just a note to say that bin-out files are generally quicker to read than ASCII files, even though they contain the same information, and that's because of the formatting and the file size. Okay, so THIS will read bin-out files quicker. Okay, so we can choose our settings for which files are read in. In Dyna, many time history data are available in more than one output file, and the formatting of the data and what it specifically has in it depends on which file it's written to. For example, if you have your global energies, they will be written in a slightly different way in the different files that it's output to. Okay, and this menu, the settings menu, allows you to decide which file you want to read in preference. So it tells you, it tells THIS, for example, for global data, I'll read the LS-DYNA database first, followed, if that doesn't exist, then I'll read the ASCII file, and if that doesn't exist, then I'll read the THF file. Okay, in some cases you won't have some of the data, in which case there will be none presented, none available for you to read in THIS. So that's all fine. That's all useful. It is important to know that when you are setting up your post-processing in your company or for a particular project, then you should be consistent with the order in which files are read. Because, as I said earlier, Dyna will output the files in slightly different ways. Okay, and this is just the interface that for reading in THIS files. I'll do a quick demonstration of this later. We can read in the THF file is the default, or some of you may know this as the D3 THDT file. Okay, we can also select or deselect any of the files that are output in your particular analysis. So for example, if I didn't want to read in some of the ASCII files, I could just uncheck this and THIS would not read those in. The default is to read in everything that is available in the folder. Okay, so once you've read in the model and you've clicked apply, then THIS displays all of the post-processing data that is available in that particular folder, okay, in that particular analysis model. So we have global data here, global energies. We have nodal data in this particular model, and then various other little pieces of data. And you'll notice that the data that isn't available is grayed out. Okay, once we select or highlight one of these output items here, we then get a submenu that tells us what is available under that particular menu. So in the case of nodes here, we can output the displacements, and we can choose which node we are plotting as well. As well as selecting things, we can left click and we can press Control, we can press Shift, or we can press Control to highlight multiple entries. We can also key in data here. So if you know the particular node number that you're interested in, you can just type that in and THIS will select that particular node from the menu. We can also select a range of nodes, for example, 1, 2, 4 to 6. That will give us nodes 1, 2, 4, 5, and 6. Okay, so that's what we'll get there. And that applies for any entity, not just nodes. Okay, once we click on apply, THIS will read in that data and plot it on a graph for us. Okay, so I'll just give you a quick demonstration now. So in this particular example, I'm just going to show you how THIS reads in files. So I'll just show in the grid. So I've got LS-DYNA here, and then I'll select my model. And then we'll notice here that there are some outputs here. I can deselect those if I don't want them. In this case, I'll just read them all in. So now THIS has read that in. It's very quick, as you can see. And I can start to read in some of this data. I'll just expand that a little bit so hopefully people can see that clearly. And then you can see what I showed you on the earlier screens. So it's all very quick. In this case, what I will do is I will select the dx, dy, dz, and the displacement magnitude. So I just pressed Shift and left click, and that will highlight all of those. And I also want to select multiple nodes. Again, I'll press Shift and then left click, and that will highlight all of these. I'll press Apply, and then THIS will plot the data. So it's very quick. Okay, obviously, if you have more data, then it will read in a bit slower. If you have less data, then it will be even quicker. Okay, so that's just a quick example. That's the first example. I will continue to give you examples throughout the webinar. The next thing to talk about is the user interface. Okay, so for users who use Primer and D3 plot, the THIS interface is very simple and very easy to pick up. All of the mouse buttons are very similar, and the user interface is very similar as well. So at the top, we have our top menu, so things like File menu, Graph menu, and so on. In the middle, we have all of our graphs. And then in the bottom left-hand corner, we have the dialog box. Our plotting controls are in the middle, and the main thing that we'll use is the curve manager on the right here. At the top, we have our tools menu. So that's very similar to Primer and D3 plot if you use those. Okay, so let's look at the curve manager. The curve manager allows you to control which graphs are plotted, and it will display, if you make an operation on a graph, for example, it will add a new graph to the bottom with your manipulation in it. We can blank curves, we can delete curves, we can show certain curves, we can hide other curves. So in this case, if the graphs that we're showing in the active graph, if we click on those, they are highlighted in green. Those are the ones that are displayed. The ones in red are still in the curve manager, but they're not shown in the active graph. Okay, so this is an example. The other thing we can do in the curve manager is to change the title of the curve. So these titles are the default LS-DYNA titles. And sometimes that doesn't really help us very much, so we can change those. So you can just literally delete the existing title and type in your new title. So that's what's been done here in this example. And that's automatically transferred into the active graph. And we can just plot that. We can update the plot by clicking on plot. Okay. The curves appear in the legend in the same order as the curve manager. Okay, so we've got displacement Y, we've got this new title, and then displacement Z. So they're all in the same order. And you can manipulate the order in the curve manager. We can use the drop-down menus to delete selected curves, or we can right-click on the number, the curve ID number, and perform individual operations on those. So we can delete individual curves that we're not interested in. Okay, so we can also read in multiple models, and that's very useful with the curve manager because we can sort either by model or by entity or even by component. Okay, the default sort is things are read in sequentially. So you'll have curve number 1, 2, and so on, and they're just added to the bottom of that curve, to the whole list. Yep. Okay. Within the curve manager, we can also format curves. So we can change the color, we can change the style, we can change the thickness of the line. We can also change the symbol. So THIS has 30 predefined colors, but there's also a palette that people can use. There are a number of symbols and a number of line widths and styles that we can choose. And this is all to help you to present your data in the most easily understood manner. Okay, so for example, we'll go through example 2 here. So I'll just bring back the same curves that I read in. And in this case, what I want to do is basically to just show you a bit of formatting that we can do in THIS, which is very easy. So first of all, I'll just blank these curves, which I don't want, and just plot these 3 curves. And these are the X displacements for node 1, 3, 4, 3, 4, 4, and 4, 5. Okay, the specifics are not important. It's just to demonstrate how we can change these. And if I click on the symbol there, I can change multiple entries. So for example, I want to make these 2 dashed. And then for this particular curve, I will change the color and I will change the line width. Okay, so that's all done and it's automatically plotted those for me. Okay, so that's just demonstrating that, this is a nonsensical example really, but it's just showing you what THIS can do very quickly. Okay, the other way to organize your curves is using the curve table. So it's another method of manipulating multiple curves. And in this case, with the table, you can group certain curves into particular groups. And then you can perform operations on a group. So as well as manipulating the actual curves, we can also manipulate the formatting area. So we can change the appearance of the graphs, we can change the titles, the menus, and so on, all the usual things. We can change the grid spacing, we can change whether it's a logarithmic or a linear scale, or we can change the number of decimal places, all of the usual things that you would expect. So that's under the title axis menu and the display menu. Within THIS, we can also plot very easily the minimum or maximum data, and we can plot the number as well on the graph. So we can do this under the properties menu. We can also move the legend. We can move it from the default bottom to a floating point, which basically means that we have the legend in a box just floating, hovering on top of the graph. And then you can drag that. You can just left click and drag that anywhere on the screen. We can also drag the axes. And we can change the formatting of the axis and the title. Okay, one of the other useful features about THIS is that we can plot multiple graphs on the same page. And what that allows us to do is to quickly show several different aspects of the post-processing in one convenient plot. In this case, what you end up with is for each graph, you have a graph tab. Okay, and each of those we can change which graphs are shown. So the curve manager stays the same. It has the full list of all the graphs, but we can select individual graphs and plot individual types of data. Okay, so there'll be a little quick demonstration of this later on. Okay, so I'll talk to you about the quick pick menu. The quick pick menu, if you've used Prime or D3 plot, is very similar. The first thing we do is select a function to perform. So in this case, the default is blanking graphs. Then if we left click on the graph, it will perform that particular function. If we right click, if we middle click, it will undo that particular function. Okay, so the most useful that I find is just left click and blanking individual graphs. Okay, but we can also do more sophisticated things like actually applying a function, a particular operation, to a graph that we click on. For example, we could apply a filtering function to a graph. And then we would just be able to click on that graph and it would perform that function. Okay, so if we left click on something, it will perform that function. If we right click, it will give you this information box and ask you what you want to do in the quick pick manner. And if we right click and drag, we can do that to multiple different curves. Okay, this is just telling you about the function that you can perform. And we can either set the output to generate a new curve or to overwrite the input curve. So the default is to write a brand new curve. So you keep your existing raw data and then you manipulate it and then you write out a new curve file. But sometimes you might not want to do that and you have the choice to overwrite the input curve. Okay, when performing quick pick operations or when performing any operation, we can actually, instead of left clicking in the menu on the right hand side, we can actually pick individual graphs on the screen. And they are highlighted as they are picked, and then they'll be highlighted here as well. And the same is true vice versa. So whichever your preference is, you can very easily determine which graphs you want to perform an operation on. Okay, so the next section I will talk about curve operations. So I won't go through all of them, but I'll go through some of the basic ones. T here says over 80 different functions for manipulating curve data. And these are divided into 4 categories: operate, maths, automotive, and seismic. Now you might find that some of the things that you want are actually under automotive or seismic rather than where you might sort of want them to be in one area. But there is a sort of logic to this subdivision here. So let's look at the operate menu. You can hover over. What happens is when you click on the operate menu, you get a sub-menu with all the different operations that you can perform. In this example, it's add y, and that means you're adding to the y values of the graph. And add x means you're adding to the x values of the graph. Okay, you can hover over a button for a description, whether it's selected or not. Okay, so I've already mentioned this slide, so you can we can do adding, subtraction, multiplication, and division. We can also do more advanced functions like vector magnitude of 2 or 3 components, the summation of multiple curves, or finding the minimum maximum of multiple curves. Okay, the automotive menu is a menu that many people will use, and this contains standard industry filtering algorithms. We also have things like the head injury criteria, the HIC criteria, and various other criteria related to the automotive industry. In the maths menu, we have things like square root, logarithm, or algebra. And in the seismic menu, we have things like response functions, and in particular, displacement velocity or acceleration spectra can be read in and converted into other formats. We also have things like Fourier transforms, that's the FFT, fast Fourier transform. Okay, so just while we're talking about curve operations, certain operations can be applied on individual curves. For example, we're clipping a curve, and that means you're truncating it. So we can either click on the curve on the screen, or we can click in the menu down here, and we can select multiple curves to clip at the same time. If we do select multiple curves, then one output curve is produced for every single input curve. Okay. The next group of operations is where you have two curves. In this case, for example, the first group could be one curve, or it could be many curves. So we've selected in this example multiplication in Y. So we could have one curve. Okay, the second group can either be a constant, where we can key in a value. So in this case, we're multiplying these two curves by 1,000, and we'll get two other curves. Yeah. Or it could be one curve, in which case we'd be multiplying these two curves by one of these curves. So then again, we'd get two different curves. Or it could be n curves, right? So, which is the same number as the input. So we could have these two curves multiplied by these two curves, in which case it will multiply the first curve selected in group 1 by the first curve in group 2, and then you'll get an output. Then separately, it will multiply the second curve in group 1 by the second curve in group 2, and you will get another output with a different curve. So that's very useful where you have, let's say you have X data and Y data. You want to multiply each of the X data by each of the Y data, and then get your XY data. Okay, one of the other things is by default, the curve input and output, both the input and output curves are kept, and the output curve is the same color and style as the input curve. And we can change this behavior. We can change the colors and so on that are defaults. We can overwrite the input curve if we want to. It's already alluded to that. Okay, so let's go to another example. In this case, I'll start again from scratch. I'm going to the read menu. I'll read in this particular graph. Okay. I'll perform a simple operation on it, which is to differentiate this curve. Apply. Okay, so we can see that the input and the output curves are the same color. So I'll just to sort of make things clearer, I will right-click on this one and change the color. So that's using the quick pick options. And I can also right-click and change the line width. Okay, so that's very good. Next, I'll read in. So what I've got here is displacement x and then displacement x differentiated. Next, I'll read in the velocity x for that same curve and apply. And the differential or the derivative of the displacement is the velocity. So we actually get the same curve, which is as we expected. So t-his, I mean, this is a simple example, but it's just showing you that t-his is doing the right thing. Okay, and what we have is one curve superimposed on the other curve. And maybe if I just change this line style to be dotted, or maybe that one is easier to see. Hopefully people can see that the red dashed line is the derivative of displacement and the green line is the velocity. Okay, so one thing I didn't mention was we can auto scale and zoom into a particular point in the curve. So that's all very easy to do and very neat. Okay, so the next thing is output options. We can write out curves, so we could just go to the right menu. We can select the curves that we want to write out, and we can choose the format that they are written out, either as curve files or CSV files or even Excel files. Okay, and we can choose which graphs to write out. If we have multiple graphs, we can choose which graphs are written. We can choose all of the graphs to be written. If you have a particularly large number of graphs, let's say you have 9 graphs on a single screen, we can actually increase the resolution to 2 times or 4 times screen resolution. And that will mean that your images are higher quality. They'll be larger as well. Okay. If I don't know if anyone uses PostScript or PDF anymore, but if you do wish to output that, we can do. And again, we have different options for orientation and page layout if you're doing PostScript. Okay, so this example will tie up a few of the things that I've spoken about. Once again, I'll just create a fresh canvas here. I'll just delete all of that. So the first thing I want to do is create 4 graphs. And I can go to the graphs, select options, and then number of graphs to create. I want 3 extra ones. So I've got 4 graphs now on the screen. Okay, I'll read in the X displacement for these 3 curves. Okay, it's plotted them on all 4 graphs. I didn't really want that, but I only want to show them on graph 1. So if I go back to the curve menu and then untick graph 1, I can blank all of those. So they'll be blanked on those 3 graphs. Okay, now I want to do an operation. So I go to operate and I want to subtract this particular node from this node. So this is subtracting the pelvis node from the chest node. And I'll get another graph there. Okay. So on graph 1, I want to show the original data. On graph 2, I want to show this subtracted data. And what I'll do to make it clear for me is just change the name there. And I'll change it to displacement. Sorry, I had caps lock on. Pelvis minus chest. And then click on plot, and that's updated. Hopefully people can see that. I know it's a bit small on the screen. The next thing I want to do is read in acceleration data into graph 3. Okay, so I'll show acceleration X for the neck node. Okay, so that's given me a plot there. And that's quite noisy there, so what I want to do is filter that. So I'll go to operate, and I want to do this in graph 4. So I want to go to automotive, and then I'll apply a C180 filter on the neck curve. So I can either click on this curve, or I can click on the screen and click on apply. Okay, so in graph 4, I want to show those two. Now again, the color is the same, so I'll just change that. There we go. So now what I'm showing here is the displacement for 3 nodes, the difference in the displacement for 2 of those nodes, pelvis minus chest, the acceleration of the neck, and the acceleration of the neck filtered. So again, I can just undock this, and I can just change the title to something a bit more sensible. There we go. Okay, and I'm very happy with that. And and I know this is just a bit of a silly example, but it's just demonstrating that you can show quite a lot of data for the same model all on one page. Okay, so the next thing I'll do is save these graphs, and I'll want to save them as 24-bit PNG, and I'll select all graphs there. So I'll just capture that. It's in this subdirectory here. And I also want to write out the curves. Okay, so I'll go to write, and then all visible, and then I'll write out the curves. So I don't know what to call this, but paired impact, and then click on apply, and that's written out the curves. And I can see in the dialog box what it's actually done, and it says successfully written 6 curves. I know that's very small writing, but hopefully you can see that. And if I go to my directory, you can just see there, and that is today's date and the time there, and that's the curve that it's written out. So that looks very nice. I think I'm happy with that. So that's good. Okay, so that's the end of that example. Let's go to the next one. Okay, so the next point I'd like to talk about is FastTCF. And FastTCF is very useful. It's a very quick way of producing plots. It's a scripting language for THIS, but unlike macros or JavaScripts, the FastTCF file is automatically generated by THIS. Okay, and the beauty of FastTCF is you don't have to remember to do it to start the recording beforehand. You can do all of your graph manipulations first, and then generate the FastTCF file. And what THIS does is it works out what you did to the input data in order to get the output graph that you wanted, and it will replicate that. And it will save that in a script. And once you've written out that script, it's written in a very simple language. And I have to say, I'm not a big programmer, but even a novice like me can edit the file manually. It's very easy to do. Once you have the FastTCF file, you can use it in batch mode to automatically post-process results. So you can run it on multiple models. You can run either the same script on multiple models, or you can run multiple scripts on the same model. And you will very quickly be able to output your graphs. It's very powerful, and it's very, very quick and very useful. Okay, so this is just briefly going through it. First, we generate the plot. We format the plot, all the curve names, all the titles and axes. THIS will replicate any changes that we make. Next thing to do is go to the FastTCF menu and then create the script. And all we have to do here is tell the script what we want to be generated. So in this case, we want the current page, and we can also request image output and the curves to be written as a file in the curve file, just in case we want to go back and revisit the data. Okay, once you've done that, that's it. We can replay the script by going to the FastTCF menu and clicking on Run, reading in that file. It's saved as an INP file, input file, and then we just sit back and let thist regenerate that plot. Okay, something similar to FastTCF, it actually uses a FastTCF, is if you have one model, you've performed a bunch of operations on it, and you've produced some output, you can read in another model and repeat all of the previous commands. So this is basically running a FastTCF script on the second model. And this is very useful for comparing model results. Let's say you have two runs and you want to know what the difference in the acceleration is. You can just do that very quickly on the fly. Okay, so in this example, I will go through FastTCF. What I'll do here is, again, I want a blank canvas, so I'm going to delete all of these, and I'm going to delete, I'm only going to have one graph, so I'll delete those just to make it easier. In this case, I'll read in something different, so let's go to dyna, contacts, let's read in the force. Right, so I've got this master force magnitude for this particular contact. What I'll do now is I want to filter it. So I'm going to filter that curve. Okay, so I've applied the filter. I'm going to change the color just to make it easier to see. And I will also change the name a little bit. I don't know what this particular curve is, but let's say pedestrian to bonnet or something like that. I don't know, it doesn't matter. And then let me filter this. Let me just say filter there. Okay, so that's the curve I want. I'm going to change the title to say impact contact force. Okay, so I've just changed the title there. So I've got the graph the way I want it to look. And now I will create a FastTCF file. Okay, so I can just change the file name. I don't know what to call it. Let's just call it FM, force magnitude. Okay, I want the current page. I want the image output. Okay, I'll just call it force magnitude. And let me output the curve files as well, because it's always useful to keep those. And click on apply. That's it. I don't need to do anything else now. That's generated a FastTCF file. Okay, so what I'm going to do now is open a new instance of this. Whoops, oh, clicked on the wrong button. So I was just opening a new instance of this. Okay, just do that. And I'll read in the same model again. Okay, and then I'll go to FastTCF. I'll run it this time. And that's the one that I generated. I'll click on play, and I don't know how quickly your screens update, but hopefully you were able to see some of that happening. And we can see that we've got all the formatting in the same way. We've got our filtered curve there in red. We've got the naming all correct. And this is the dialog that has been produced afterwards. And in the folder, in that same folder, I asked for this particular image. And we can see the date stamp, the timestamp is just, that's the one that we just created. So that's very good. I'm quite happy with that. I'm quite happy the demonstration worked as well, so that's good. Okay, let's get back to the PowerPoint. I've only got a couple of extra slides now. We're almost at the end. One of the other useful features of TES is macros. And what these allow you to do is quickly run through a set of commands that you use frequently. And you can save the macro in a macro library, okay? Now, effectively, the macro is just a fast TCF script, and it just has some additional lines to specify that it's a macro, and you can have this little macro function button that appears. Okay, and this is an example of a macro. I don't intend to go through it, but yeah, that's it. That's a very brief overview of TS, but actually we've covered almost all of the main functions and the items that TS will perform. So that's the end of my presentation. If anyone has any questions, please do type them in to the box. But if not, as I said, the presentation material and the webinar recording will be available, and we'll send out the links to everyone that attended. So thanks very much. Thank you for listening.